Water cycle describes movement of water between the different spheres of Earth, and again, like the carbon cycle, water is a very important molecule for the support of life processes on Earth. It's one of the foundation molecules which is absorbed by plants through their roots and incorporated with carbon dioxide to make sugars. So the availability of water is very crucial for the fundamental production of sugars from plants through photosynthesis, which is the basis for providing the food resource that will support that whole food web of whatever ecosystem those plants are part of. So providing sufficient water to plants is very important to provide the foundation input of resources to increase productivity, and also, you know, for the animals or birds or whatever it is within the ecosystem, they'll need a fresh, clean source of drinking water for the support of their own health. But if we look at how water moves around the different spheres on Earth, we could probably start with the evaporation. So if we look at, again, the sun and the role the sun plays, the heat from the sun will cause the evaporation of water from its catchment in oceans and rivers and lakes. And as the water evaporates up into the atmosphere, so it's moving from the hydrosphere up into the atmosphere, it will start to condense because it's colder up in the atmosphere than it is on the surface of the various water bodies that are receiving this direct sunlight. So as it cools down, the water vapor is going to condense into liquid water and will be pushed in those clouds often onto mountain ranges on the nearest continent. And as those clouds are pushed up the sides of the mountains, they're cooled even further, and anytime you get a cooling of the water that's in clouds, you get the rain falling as precipitation. So whenever you get clouds pushed up a mountain and the water cools down as a consequence of that, it will start to rain. So the precipitation of water will then flow into that whole catchment. So when you're considering the impact of water entering into any particular stream or river, or its flow through the landscape that's on your farm, you've really got to consider how it's part of a bigger catchment, because any water that falls at any point on that catchment will flow through that catchment and down into the streams and rivers and down into the lakes and rivers. And in the process of doing that, it will carry any sediments that are loose in that system, any water-soluble nutrients that are been applied to that system, and it will carry all those sediments and nutrients into the rivers and lakes and oceans. So we've got to be very careful in how we manage this landscape, that there isn't loose sediments that are going to be moving with the water and clogging up our rivers and lakes and oceans, and that there's not an excess of water-soluble nutrients due to excessive fertilizer use also being absorbed into that water and being carried down into the rivers and lakes and oceans. But the two pathways that will happen is either the water that falls in the catchment will be collected into the streams, lakes and rivers, or it will infiltrate and percolate down into the groundwater, and it can be stored in that groundwater for thousands of years. It can become fossil water, so it can just sit in that groundwater for thousands of years. And again, there's a link between, you know, agricultural land use and water moving down into the groundwater, because if it sits there for, you know, potentially thousands of years and it's absorbed various nitrates and agricultural chemicals on the process, those chemicals and nitrates are going to be stored in that groundwater and going to impact future societies for thousands of years. So we've got to be very careful of the legacy that we leave future generations, because we're storing all those chemicals deep down in our soil and deep down in our groundwater, and it's going to take a long, long time for those chemicals to be able to be broken down by biological systems and made clean again. So that's the lithosphere, so that's the movement of water from the atmosphere as clouds, and as it rains it's entering into the lithosphere as it rains on the catchment, and then eventually the water will move through the lithosphere or through the catchment and enter back into the hydrosphere, so back into the ocean, lakes and rivers. But in the process, water is also going to be absorbed by plants and be converted along with carbon dioxide into sugars. And also the water will be drunk by various animals. And through the process of being drunk by animals or being absorbed by plants, it's going to enter the biosphere. And it's this entry point into the biosphere that again we're most interested in, but we've got to have a look at the sources of water and how they fit into the overall picture. So how water's moving through the catchment, how water's moving into our groundwater, how it's entering our streams, being evaporated from surface water, and also through transpiration. So trees will lose water, and by losing water they help draw it up. And that process is important for actually increasing the humidity of the air around forests and increasing the rainfall around forests to support the continued growth of those trees. So that the trees are actually changing the atmospheric conditions around them and humidifying the air to increase the amount of rainfall around them, which is to their advantage because they can then absorb that water through their roots to be able to photosynthesize more effectively.